we are going to go over Part A of the August 2019 Chemistry Regents exam. For Part A, we're talking 30 questions. They're all multiple choice, and they are definitely heavily based on definitions and facts. So if there's anything here you're getting wrong, my suggestion, you write it down and make sure you study it before you go over more questions. And if you could, subscribe to my channel, NY Chem Coach, to get the latest updates as I add the other parts to the August Regents and more information as the year goes on. I'd appreciate that. So let's get started with number one. What statement describes the earliest model of the atom? You might remember from being in class that there are several models that we went through as new discoveries were made based on experiments. But the very first model was that the atom is an indivisible hard sphere. 2, 3, and 4 came later on. So the answer for number 1 is choice 1. For number 2, all atoms of bismuth, the number of electrons must equal. If you have an atom, remember atoms are electrically neutral. Your electrons are negatively charged, your protons are positively charged, and your neutrons, yeah, you can say they're neutral or they have no charge. So what does it mean when atoms are neutral? The number of electrons must equal the number of protons. For question 3, we're looking at which symbol is going to represent the mass of a particle that's equal to the mass of a neutron. This is a fact you should already know, that the mass of a neutron is approximately equal to the mass of a proton. So that's what you're looking for here in the choices. But they didn't make it easy on you in that they gave you these other symbols. Number 1 is an alpha particle, 2 and 3 are beta. 2 is a beta positive, known as a positron. 3 is beta minus. We also call that an electron. It's number 4 for proton. Now, there is a reference table that has these symbols and what they mean. Let's take a look. We're looking at reference table O, and here's my neutron and my proton, and both have a mass number of 1. So they have essentially equal masses. That was the answer. For question 4, we have one of the vocabulary words that shows up pretty much on every exam, and that is the word orbital. And it's the region in an atom where we have a high probability of finding an electron. Make sure you know the vocabulary word orbital. For number 5, which electron shell in an atom of calcium in the ground state has an electron with the greatest amount of energy? But we're looking for calcium, we're looking for the shells. Remember, electrons fill these levels or shells. We go from closest to the nucleus to farthest away. We can find the electron configuration for calcium on the periodic table, on the reference table. You also need to know the symbol for calcium. Now, it's a fairly easy one because it's Ca. If you don't remember the symbol for an element, you're going to go to reference table S. Let's head over to the periodic table. Here we are at the periodic table. I've circled calcium. We have an electron configuration of 2882. In other words, there are 4 levels or shells. The further out electrons are from the nucleus, the more energy they possess. So that is going to be the 4th shell or level because it goes up to 4 for calcium. The answer then for question 5 is choice 4. Question 6. As the elements in period 2 are considered in order from lithium to fluorine, there's an increase in you're talking here the periodic trends. The size of the atom, known as atomic radius, that can be found on reference table S. Can't really draw an S so good. Electronegativity, same thing, reference table S. The number of electron shells, that is determined by the period number. And what that means is that they all have 2 electron shells. So right away, that is not the answer. We're looking for an increase in the number of electrons in the first shell. That's not going to be any different because the first shell, they already all have 2 electrons because we're starting with lithium, which is element 3. It has 2 in the first shell and then 1 in the second. So every element going from left to right is going to have 2 electrons. So that can't be the answer either. So it's between atomic radius and electronegativity. Now, you could pick out some elements on reference table S. However, you might remember, right, if I have lithium and I'm going across that row and we're going to fluorine, fluorine is the most electronegative element on the periodic table. So obviously electronegativity is increasing and choice 2 is our answer. Atomic radius, as you would find out using reference table S and picking out just maybe lithium, another element, and then fluorine is decreasing. Again, always use reference table S, but the answer here is choice 2. We're going to move to question 7. Which element is classified as a metalloid? And a metalloid is the same thing as calling it a semi-metal. These are the group of elements that are between metals and non-metals. There are 6 that you have to memorize. Let's see where they are on the periodic table and we'll know what choice is the right answer. In knowing what your semi-metals or metalloids are, you're starting with boron, silicon, arsenic, tellurium, and then 2 underneath. Now, you know aluminum, like aluminum foil, is a metal, but germanium and antimony are also called semi-metals. So it is these 6. You need to know them. You need to memorize them or be able to look at the periodic table here and pick them all out. Starts with boron on what I call this staircase or this bold zigzag line. The answer for number 7 is choice 1, boron. For number 8, we're looking at strontium and barium, and they have similar chemical properties because atoms of these elements have the same number of. Well, we want to take a look at where strontium and barium are on the periodic table. Now, you'll notice several times, in fact, every single time so far on this page, you're not given any element symbols. You're given the element names. If you do not know what the element symbols are for strontium and or barium or anything else on this page, take the time to go to reference table S and find it. You don't want to make a mistake when the answer is right in front of you. Let's check out the periodic table. Okay, so we have strontium and we have barium. So they are in the same group, the alkaline earth metals, and they share similar chemical properties because everything in group 2 has 2 valence electrons. Obviously, things like the number of protons, neutrons, and electrons is not going to be the same. With that information, let's go back to the question. And there it is. They have the same number of valence electrons. For number 9, which term represents the fixed proportion of elements in a compound? Fixed proportion is a chemical formula. Plain and simple. It's a definition for chemical formula. And I already mentioned you need to know your definitions, you need to know your facts, and you need to know where to look on the periodic table among all the other reference tables. Okay, which 2 terms in number 10 represent types of chemical formulas? Mechanical formula? No. Mechanical and thermal? No. Molecular and structural? There it is. There are molecular formulas, that's right, the arrangement of atoms, right, based on the bonding. And of course, the structural formula is where, again, we see the structure. So the answer for 10 is 3. Moving to 11, which element has metallic bonds at room temperature? In other words, which of these 4 elements here consists of a metal? Once again, I am not given the symbols, but I can certainly locate metals versus semi versus non-metals on the periodic table. But it would be nice to have what element symbols they are. Don't do it off the top of your head if you're not sure. Go to S. Of course, bromine is Br, so we're going to look for Br. We're going to look for Cs for cesium. We are going to look for krypton and sulfur. All right, so here's Br. That's a non-metal. CS, well, that's our metal, but let's look for the other two: sulfur, non-metal, and krypton, non-metal. So this is our dividing line. So here it is. Cesium is the winner. 2. Let's check out question 12. What is the number of electrons shared between atoms in a molecule of nitrogen, better known as N2? To nitrogen, the attraction is a triple bond, and that is because nitrogen as an atom has 5 outermost or valence electrons, and it wants to get to the magic number of 8. It forms 3 bonds, but remember, when you're dealing with non-metal, and they're sharing, each bond is 2 electrons. 2 times 3 is 6. Question 13. Given the equation representing a reaction, typical Regents question, this shows up a ton of times: hydrogen atom plus another hydrogen atom and forming a hydrogen molecule, or H2. All you have in this reaction is the coming together of atoms, and of course that would be in a bond. So a bond is formed. First thing, let's get rid of choices 1 and 2. And when a bond is formed, always, always, always energy is released, and that is choice 4. See, there's no bonds being broken here. These are already atoms. Chemical reactions, typically you're breaking bonds on the left-hand side with the reactants, and you're forming new bonds on the right-hand side as the products. So if you're breaking bonds, you're putting energy in, or it's being absorbed, and when bonds are forming, it's being released. This is only showing you one step, and that's why the answer is choice 4. For question 14, an atom of which element has the strongest attraction for electrons in a chemical bond? This is the definition for electronegativity. You have to recognize it. Notice they didn't use the word electronegativity, but that is the vocabulary word. So once you realize that and identify it, real simple. You're going to go to reference table S, and you can pick out which one of these elements has the highest value. You could also look at the periodic table and figure out which one is closest to fluorine, because fluorine has the highest electronegativity. But notice, once again, they're giving you the element names and not the symbols. You're only seeing the symbols on the periodic table. So let's face it, let's just go to reference table S. At reference table S, I circled the 4 choices. Carbon is 2.6 for electronegativity. Down here we have phosphorus, sulfur, and chlorine, and you'll know notice chlorine has the highest value. That is your answer. Checking out question 15, we have a 50-gram sample of water in the liquid phase and a 100-gram sample of water in the liquid phase. You have the same substance in the exact same phase. They are going to have the same chemical properties. It doesn't matter how much of it you have. So your answer right away is choice 1. Moving on to 16, which statement describes a mixture of sand and water at room temperature? Well, you know sand doesn't dissolve in water, and even if it did, whether it dissolves or not, you have a mixture, and you have your heterogeneous or homogeneous. The sand is going to fall to the bottom, so it's going to be heterogeneous, so cross out 3 and 4 because it's not homogeneous, and then it's asking if it's in the same phase or not. Sand is a solid, water is a liquid, so different phases, or choice 2. For 17, distillation is a process used to separate a mixture of liquids based on. Distilling is based on boiling points. There are some other separation of mixture techniques that you need to know, and you need to know what physical property separates them. Check them out. For example, filtration, particle size. Chromatography, it's going to be the what we call the molecule polarity, or really the solubility, right? What mixes with what. So you need to know that. It is a fact. Moving on to question 18. It says, according to kinetic molecular theory, which statement describes particles in a sample of an ideal gas? No actual gas is an ideal gas, but we call them ideal gases because then we use the gas law calculations, which are an oversimplification of calculations, but it works fairly well. And the kinetic molecular theory, again, this oversimplification describes the atoms or molecules that make up a gas as only moving in straight line paths. That the collisions are elastic, which means they're not losing any energy. That even though the atoms or molecules that make up a gas might have attractive forces between them, we're going to ignore it. And we're also going to ignore that gas particles themselves take up volume. So we're looking, we got to watch the wording here, right? Which statement describes the particles in a sample of a gas? So this is a true statement. Are they constantly moving in circular paths? That's false. That's not the answer. When they collide, is it decreasing the total energy of the system? No, that's not true. That's not the answer. The particles have attractive forces between them. That is true, but we ignore it when we're dealing with an ideal gas. That's not the answer. It is choice 4, that the particles of gas are considered to have, I can't say the word too well, but this means that we're ignoring the volume. It's negligible. Ooh, that was tough, but I did it. Question 19. Which sample of matter has the greatest distance between the molecules? Of course, you know that means anything in the gas phase. You're going to have energy and they're going to be separated apart. Right away, here it is, choice 1. For question 20, we have a system in equilibrium. The concentrations of both the reactants and products must be constant. That's it. What's equal in an equilibrium is the rate of the forward and the rate of the reverse reaction. Concentrations for reactants and products are constant. Know it. It comes up all the time. Finishing out this page 21 in terms of disorder and energy. Systems in nature tend to have a tendency to undergo changes towards. It's a fact, Jack. You need to know it. They like greater disorder, meaning randomness. So right away, cross out 1 and 2. And they like the particles to have lower energy. So that is going to be greater disorder, lower energy, choice 3. Check out 22, the only 2 elements in alkenes and alkynes. This is organic chemistry. There are 3 reference tables. If you don't remember, the 2 elements we're talking about are carbon and hydrogen. And to round out this page, for 23, which functional group contains a nitrogen atom and an oxygen atom? For functional groups, let's head to the reference table. So here we are at table R. Literally what we're looking for is a group that would be on a molecule that has oxygen and nitrogen. We need to scroll down. The last 2 groups contain nitrogen, but if you take a look, the only one that has oxygen is an amide, so that is our answer. And that means then for 23, it is choice 3. We are moving right along to question 24, and it's asking, we have a sample of magnesium solid reacting completely with oxygen gas. If the magnesium atoms are losing a total of 5 moles of electrons, how many moles of electrons are gained by O2? It's got to be equal number of moles. Whatever one loses, right, which is oxidation, the other gains. So the answer here for 24 is choice 3. Now, I could see a student getting confused if they go through the whole thing and try to write out half reactions, but it's as simple as the total moles lost have to equal the total moles of electrons gained. Let's go to 25. Question 25, which statement describes reactions in an electrochemical cell? So an electrochemical cell could either be a voltaic cell or an electrolytic cell. And what do we know? We know oxidation is loss of electrons, Reduction is gain. That's the Leo, the lion goes grr. And we also know anox, red cat, meaning that oxidation occurs at the anode and reduction occurs at the cathode. And sure enough, look at that. It's right here. Choice 1. It's a fact. Make sure you know it. 26. 0.05 molar aqueous solution of which compound is the best conductor of electric current. Your best conductors are going to be your soluble salts, your acids, and your bases. Typically, your organic compounds are not great conductors unless they're acids and they break apart into ions. Choice 1 is an alcohol that does dissolve in water, but it's not going to break apart into ions. We need moving charges or ions in water, so that's not going to work. And glucose, while it dissolves in water, that's not going to work either. Our two choices then are magnesium sulfate and potassium sulfate. We need to go to the reference tables and find what is soluble of these two salts, and whatever is soluble, it's going to break apart into ions. Not only is it going to break apart, but notice the formulas, right? Magnesium sulfate is a 1-to-1 and potassium sulfate is a 2-to-1. Let's check it out. So I come to reference table F, and sure enough, I'm just going to go ahead and start from left to right. I'm looking here at the soluble column, the first column, and here's sulfates. Here's exceptions. These would be insoluble if sulfate was with any of these metals. You'll notice magnesium and potassium, they're not here, which means they're both soluble. Great, that means they both break apart. But remember, it was asking what's the best conductor. Magnesium sulfate will break apart into 2 ions, where potassium sulfate, because you have 2 potassiums for every 1 sulfate, you get 3 ions. That makes potassium sulfate our answer. Question 27. What is the color of brome cresol green indicator in a solution with a pH value of 2.0? Again, I have to go to the reference tables. I'm looking for the acid-base indicator reference table. Let's go ahead and do that. We're dealing with brome cresol green. pH was 2.0. When I read this table, the range for the color change is from 3.8 to 5.4. That is higher than 2.0, which means it was yellow. So yellow to blue means that anything less than 3.8 is going to be yellow. Between 3.8 and 5.4, it's going to transition from yellow to blue, in other words, green. And then finally, greater than 5.4 would be blue. Yellow is our answer, and that is choice 4. For 28, which formula can represent hydrogen ions in an aqueous solution? Hydrogen ions, of course, is H+. The other way it's represented is the hydronium ion, which is H3O+, which is water with H+ on it. For 29, in which reaction is an atom of one element converted to an atom of another element? The only time this is going to happen is with nuclear reactions. And that means that the nucleus is changing and we have transmutation. And finally, for question 30, we're at the end of part A. In which type of nuclear reaction do nuclei combine to form a nucleus with a greater mass? Combination means you have fusion. Fission is the breaking apart. Alpha and beta decay are what's known as natural radioactivity. So the answer for 30 is 3. This ends part A. Keep working hard. Subscribe to my channel if you haven't already, and good luck.